Now we are given a string and we need to find the longest length of the palindromic sequence. So for example, we have this. A palindrome reads the same forward and backwards. So over here the answer is 4. Now think about the smallest problem, like whenever I see a DB problem involving a string, I want to ask, can I define the answer for a range of the string? Now, what happens if the two characters are equal, right? If the two characters are equal, I can use both of them as the two ends of a palindrome. So I just need to find the best palindrome inside them. So that's why if I have 2 pointers on these two ends, if I need to find the palindrome inside, I'm going to move 1 pointer forward and another backward. So I plus 1, if I use a pointer I and j on both ends, then it will be I plus 1 and j minus 1. And then I can add the matching characters, like the count of the matching characters. So I've already written the solution over here. So we start with getting the length of this string, then get the DB table, and then in this DB table, this is the base case. So this is the base case, which means for every single character, it's a palindrome of length 1, so I assign it. Now also, I am moving the pointers in different directions. So the ith pointer is going to go in the opposite direction. So it starts from the end and go backward. And the j pointer starts from, it goes forward. So it starts from I plus 1 up to the end, which is n. And then I will check if the both characters are equal. So if the both characters are equal, as I said, I'm going to move both the pointers inside because I want to check the best palindrome inside. So I plus 1, j minus 1, and then I will add the two matching characters, which is 2. If not, then I will try both. So either I get the max of when I move ith inside, so one of the pointers forward, or when I move j backward, so on the opposite direction. So whatever the max of this is, I will store that. And at the end, I'm returning 0 n minus 1. So I have a grid over here that I've already written. So the way we are filling this grid, this DB grid, is that I goes from bottom to top, and then j is over here, and j is going from left to right. So the last value that gets filled in this DB array is this, which is 4. I was just checking an example, but which is this one. So this is DB of 0 n minus 1, because this will be the last value that gets filled. So when we're filling this problem with this DB grid, we will always look at the below value. So a below value will be I plus 1, and your column stays the same, so j. Your left value will be j minus 1, so that will be the column on the left. And then you look the diagonal, so which is down and left. So if you're calculating this and you look at the diagonal, so down and left becomes this value, so which is I plus 1, so bottom row, and then on the left, column on the left. Now the time complexity of this solution is O of n square, and the space complexity is n square as well. But if you look at the solution, we don't need to consider the whole grid at any point. As I said over here, at this point, we just need the current row, and we just need the previous row, because those are the only values that we use to calculate what to fill in this DB grid. We are never considering the whole grid at one point. And therefore, I also have a space optimized version that I've written over here. So in this space optimized version, what I am doing is that I'm starting in a similar way, but I'm also keeping track of a variable which is previous. And the reason why I'm keeping track of a variable which is previous is because I will calculate the value of dp of j, but it will be overwritten. So at any given point, when I recalculate the value of dp of j, which is your existing value that you are calculating, it will get overwritten. Therefore, I'm keeping a track of a previous variable so I can store the dp of j in a temporary variable and then reassign this temporary variable to the previous variable. So I'll explain it more in depth. So similar to the original solution, we are going to start with a base case, which is over in this case, which is here, because in one dimension array we can just represent it very fairly. Instead of doing like a whole for loop like we did over here, we can just do this. So we can just assign the dp to 1 times of n, and then we still go backwards. So in the 2D version, we process I backwards like over here, because we are relying on values from the previous row, which corresponds to I plus 1. In this case, we are still going backwards. Now is the tricky part, which is the previous variable. Now, if previously when we were calculating dp of ij, when s of I and s of j was equal, the formula was dp of I plus 1 plus dp of I plus 1 j minus 1 plus 2. But in this 1D array, we do not have I plus 1 and j minus 1 because it's just one array. So instead, what we need to do is, what I'm doing is I have a previous variable which I'm assigning it to be 0. Now, suppose that we are moving from j minus 1 to j, so we are moving forward. In this case, we are going to end up overwriting our values because we are moving forward, right? And that's why we are going to save our old value, and that's why I'm going to save the old value over here in this temporary variable. So dp of j, the value that we are considering that we are going to recalculate, it already has a value, right? So I'm going to store it in this temporary variable. Now, this stored value, as we process the next iteration, when we re-enter this for loop again, will become I plus 1 dp of I plus 1 j. So the value that we just calculated, for example, over here, will be this value before it is recalculated, because right now we have not done any calculation for dp of j. So assume this is our first loop. Now assume if you are in your second iteration of this for loop, so we have not done any calculation for a new calculation for dp of j. So the value that will be reassigned will technically be dp of I plus 1 j that we calculated over here, like will be equal to dp of I plus 1 j, because that's the value that we are getting from the previous calculation, which was technically the previous row, which was the row below. And that's why dp of j, technically it's equal to dp of I plus 1 j, same as dp of I plus 1 j. Now we are doing the same thing. If s of I equals to s of j, dp of j, now is the recalculation part, is equal to previous plus 2. Now over here at the end of the loop, I'm reassigning previous to temporary. So when we enter the next iteration, previous will hold the value of temporary, right? So that technically becomes dp of I plus 1 and j minus 1. And we are doing the same thing, which is adding 2 over here. Hopefully that makes sense. Because why is it dp of previous equals to dp of I plus 1, j minus 1? Because if we have entered the next iteration, then it is the previous value, like we are in the next iteration, so it's for the one that we calculated before, and then we add 2, else dp of j equals to max of dp of j. So dp of j itself, now this over here, dp of j itself, we have already we have not recalculated it at this point, right? This is what we are considering. So this is not the recalculated version. So this is technically dp of I plus 1 j, like similar to this, because this is the value we are going to calculate. But before the calculation, it holds the value from the previous row calculation that we did, which was for the row below. So that becomes dp of I plus 1 j, and dp of j minus 1. Now this is the one before, so the recalculation for this has been done in the iteration which was before. So technically this is dp of I and dp of j minus 1, so same as over here. Then we reassign previous to temporary, which is what we did over here, and then we return n minus 1, which is the last value in the dp array that we calculated. So this is a little confusing, but if you do a couple of questions, you will get a hang of it.